Good evening, sir.
Good evening, ma'am. Let us give 5 minutes. Just now it is over, no, madam. Give another 5 more minutes.
Okay, sir. Okay, sir. No issue, sir.
The 5 more minutes for the participants, madam. Let us begin by 6:05, madam. Okay, madam. Our next session expert also has joined. Bharati madam has joined.
Okay, sir.
Madam, am I audible, madam? Yeah, Bharati madam also has joined. So we will start by 6:05, madam. Okay, ma'am.
Okay, sir.
Okay, thank you. Ma'am, Durga ma'am.
Sir.
I think we can begin now, madam.
Okay, sir.
You
Okay.
just, yeah, you welcome and introduce the
Yes, sir.
the speaker of the session, please, madam.
Yes. Good evening, everyone. I welcome the resource person, all the participants, and also the faculty members to the session 2 of day 4 of our 5-day online faculty development program on advanced signal processing communications using AI and ML techniques, which is organized by Department of Electronics and Communication Engineering, and it is a joint collaborative of two institutes, GMR Institute of Technology Raja and Sri Sai Ram Institute of Technology. Once again, I welcome all the participants. I would like to take this opportunity to introduce our today's resource person, Dr. B. Bharati Madam, to our participants. Dr. Bharati is currently working as professor in the Department of Computer Science and Engineering in Satyabhama Institute of Science and Technology. She has a teaching experience of more than 17 years. She has guided more than 50 projects in both UG and PG levels. She has published technical research papers in many referred conference and journals, both at national and international levels. To her credit, she has 72 Scopus indexed publications and 16 Web of Science indexed publications. Her H index is 8, and she also has 6 Springer book chapters. She also has 1 patent which is granted and 2 patents were published. She is a member of Asian Regional member CDIO and also a member of ACM, ISTE, IAENG, ACEEE, IACSIT and UACEE societies. And Dr. Bharati is also acting as doctoral committee member in Anna University and Wales University, and she is also reviewer of many international conferences and reputed Web of Science journals. She is editor for Journal of Web Engineering, Journal of Software Engineering, Information Sciences and Computing Journal. She is a certified rational ROAC trainer, completed Cambridge University's teaching methodology training, and she authored book chapters for data structures and advanced data structures for Satyabhama University, which is published by Charulata Publications. She has acted as keynote speaker and guest speaker in many national and international events and also conferences. Her research interests include software engineering, performance evaluation, software architectures, software testing, predictive analysis, machine learning, and IoT. We are very glad to have you as resource person for our FDP, madam. We welcome you once again. Thank you, madam, for accepting our request.
Thank you, ma'am. Thank you so much for the introduction. Just give me a minute. I will just open the PPT. Okay. I hope my screen is visible to you, ma'am.
Yes, ma'am. It is visible,
Okay,
ma'am.
Thank you, ma'am. Thank you so much.
Thank you, ma'am. My pleasure.
I take this opportunity to thank Kannan sir for giving me this opportunity to share some insights that I have on machine learning with you. Thank you, Kannan sir. So we will start with the presentation. Thank you, sir. We will start with the presentation today. The entire idea of the session would not be to load you with lots of information, but to just give you an idea of what machine learning is, what are the various perspectives of machine learning that we have, various applications of machine learning that I currently have, and how machine learning has taken entire paradigm shift in the technology industry. Okay, and I would also try to pinpoint certain prospects of machine learning and give pointers to you on what programming languages or what kind of technology you will have to keep updating yourself on to be into the field of machine learning. So that will be the entire gist of today's session. Okay. So this is a very relevant and a famous saying. Computers are able to see, hear, and learn, and so you are welcome to the future. This statement was a miracle, was an impossible statement 2 decades back. But now, with all our smart devices around us, okay, it's not only computers. When I say computers, I'm talking about every computing device that is around us. All smart devices are around us. Okay, your smartphone, your smart Fitbits, your smart watches, your smart shoes, okay, smart TVs, smart fridges, okay, smart electrical appliances, everything which is around us, which is smart, okay, meaning which is connected to the internet, are able to tap the behavioral and personal information about the user. So this is why we say that every smart device is able to see us, hear us, and learn from us. Okay, so the point of the proverb, or the point of the quotation was, we have large amounts of data which is being accumulated from us by the internet or in the internet. There's a large amount of data which is available. So people started understanding, or people started questioning themselves on how to positively use this data in order to bring in intelligence into a system. Okay, so when this idea of making a system think by itself, or making a system intelligent by itself, okay, opened up the doors of a concept called as artificial intelligence. So when I say artificial intelligence, I'm trying to artificially incorporate the knowledge of a human being, or the ability of a human being to question, to understand, to perceive, to analyze, and to perform things better, or to learn better. Okay, so intelligence requires a lot of knowledge. Okay, as a human being, knowledge is being taught, knowledge is being learned, knowledge is being observed from the environment. Now we want to mimic the same behavior from a machine. So when we start thinking of making a machine become artificially intelligent, it's called artificial intelligence because machines are not inherently intelligent. Human beings are inherently intelligent. Okay, so when you are trying to mimic this ability of a human being artificially into a machine, it's called as artificial intelligence. So this requires a lot of knowledge collection, knowledge generation, and so on. So this led to the need of a field called as machine learning. So I want my machine to learn. Okay, so what is learning? You are making a machine, or you are incorporating the ability of performing a task into a machine, okay, based on some inputs. So when I say learning, there are only two types of learning, or there are only two ways in which we look at learning. One is by acquiring knowledge. Okay, whenever we say learning, we say, okay, acquiring new knowledge. The knowledge can be either by in terms of facts, okay, or in terms of skills. Okay, you say somebody is learning when they learn some textual content. Okay, so they are learning facts, or they learn certain skills, either dancing or singing or performing some arts or skills, something like that. Okay, and the second way of measuring, or the second way of mentioning learning, is by adapting a behavior. Okay, so you are trying to increase the behavior of, increase the ability of problem solving. Okay, so that is called as learning. Or you try to solve problems more efficiently. Okay, rather than before, you try to find out more methodologies to solve the problem. So when these behaviors are built in, then we say that the system has learned to learn. Okay, so what is learning actually? Learning is a process in which the system improves performance by experience. Okay, to give you an analogy, so if you ask me to do a painting today, okay, I have no knowledge of drawing, I have no knowledge of painting. So if you ask me to do a painting today, my performance, or the goodness, or the efficiency of my painting will be completely zero, or maybe on a scale, if I measure on a scale of say 1 to 10, maybe it will be on a scale of 1. Okay, but if you train me over a period of time, say after 6 months of training, if you ask me to paint, maybe I'll be little better. Okay, on the scale, my performance may increase to say 3 or 4. After say 1 year, it can increase to some 5 or 6. after say 2 years or 3 years, my performance may increase to 7 or 8. Okay, so by experience or by opening myself into an environment, or by giving a knowledge or learning, the performance of the system increases. So if this happens, then we call this as learning. Okay, so there are a number of tasks which are connected to learning or which are related to learning, but we will try and list only those facts or those tasks which are very closer to, which sound very close to artificial intelligence. So such tasks are classification, categorization or clustering, problem solving, planning, control, prediction, etc. There are a number of tasks that we call as learning, but I'm trying to just figure out certain, or I'm just trying to list out very few here. Okay, so we have something called as intelligence, and we want to put this knowledge of intelligence into a machine. So we call this as artificial intelligence. Now, how do I correlate these two? Or how do I relate these two? How do they sound to same? Okay, say for example, I am a human being and I have been taught, okay, that a tiger is a wild animal, okay, or fire is very dangerous. I should not be going near fire, or I should not. Let us take this wild animal example. So I should not be going near a tiger because tiger is a wild animal. It's a ferocious animal. Okay, once you go near it, you are at danger. So this is a memory that I have been taught over a period of time, that I have generated over a period of time. Okay, so based on this, I have my own perceptions. So whenever I want to see a tiger, I make sure that I see it from a very long distance, a safer distance, or at least if I'm in a close distance, then I make sure that it is inside a cage completely locked. So this is my perception about a tiger. All of us would have seen a tiger, but let us assume, even if I have not seen a tiger, my perception is it's a ferocious animal and I should not be going near it. Okay, so that is my perception. I have my own knowledge generation, which is done because of the memory I have. Now I have my own anticipations. So say for example, I see a tiger, okay, at a given distance. Okay, now I will start anticipating whether I am standing in a safer distance. Should I be moving away from that place, or what should I be doing? Okay, so based on that, this I can go in for a problem solving. Okay, say for example, the tiger comes closer. Immediately my problem solving skill starts working. Okay, I start thinking whether it is inside the cage, whether the cage is properly locked, or whether I should be running from this place. If I run, where should I run? Should I climb a tree, or whatever it is? So that is called as problem solving. So I try and analyze all possible methods of coming out of the problem, and finally there is a decision making. So the decision is the optimal decision. See, whatever I told you are possible solutions, but I try to figure out the optimal solution or the best solution of all the given options. So this is called as the decision making ability. Now, now our aim is to bring in this quality into a machine. So I want to find out some equal words of this into a machine. Okay, so memory is what I call my domain data. So I collect all relevant data about my machine, about the particular animal or whatever it is, about the particular situation. Okay, and my perception starts as dialogue and conversation. Okay, I have my own questions, my own answers. So my perception is related to, or is equated to my dialogue and conversation. Then I do my anticipation and problem solving. I think, rethink, I analyze situations. So I use all the natural language skills, okay, and computer vision, seeing something and analyzing, trying to understand the entire scenario. So that is my computer vision. And finally, I try to apply my decision making skills, which is my applying machine learning algorithms. So we have tried to equate every vocabulary that is available as human intelligence to a machine intelligence or to artificial intelligence. So this is how we keep equating them. Okay, so this is something called as augmented intelligence. Okay, you're trying to add on in values, or do value addition to the normal intelligence that a human being has. Okay, now because we spoke about this example, okay, we understand that machine learning is not an independent field which is related only to computer science. Okay, so it is an encumbrance of so many interrelated fields. Okay, so when I say I have to collect a lot of data, I'm definitely talking about databases. Okay, and generating information from the data, I'm talking about data mining. Okay, We were talking about computer vision, seeing something, analyzing something. I'm talking about cognitive science, okay, decision theory, neuroscience, how my brain works or my brain decides, okay, and about various psychological models, information theory, statistics, etc. So machine learning is a collection of all this together, is the added advantage of working in the field of machine learning. So that is why it is not only the computer science engineers who excel in the field of machine learning. Most of the time it is the statisticians and the mathematics people who have an upper hand on the field of machine learning. It's because it involves a lot of cognitive theory, statistical inference, and information theory. Okay. And there are also people from the field of bioinformatics and biomedical working. It's because we are also talking about something related to cognitive science, neuroscience, and psychological models. Okay, so what can a machine learning algorithm do, or what do we mean by this machine learning? What can it really do? What is the power of machine learning? Okay, one is, say, there are various abilities that the machine learning algorithm can do. Okay, we are trying to make a system learn like a human being. So I listed certain learning abilities like classification and clustering. So we'll just try and understand what is that. So when I say classification algorithm, I'm just trying to find out what category of object this belongs to. Say for example, we'll take a example of a toddler at home. Okay, if I show certain fruits, certain vegetables to the toddler, I want the toddler to identify whether it is a fruit and what type of a fruit it is. Okay, this is called as a classification algorithm. Okay, then at anomaly detection, what is different or what is strange? Say we have a surveillance video, okay, and you want to find out what is the different behavior from the normalcy, okay, an anomalous behavior in the video. Okay, for surveillance in various railway stations and public places, you have this anomaly detection algorithms in place. This is an example of machine learning algorithm. Okay, sometimes we want to predict, okay, the rains have been so much in the past 5 years. Now you want to find out whether the year 2022 will have higher large amounts of summer or large amounts of rain. This is, we are trying to predict the future, so it is using a regression algorithm. Okay, you want to find out how you have to put the data or cluster the data or group the data to which group it belongs to. So you want to categorize your students as average, good, and better. Okay, so this is an application of clustering algorithm. And the next is reinforcement algorithm. So you want to understand what to do next. Okay, I'm not happy with only description, or I'm not happy with only diagnostics, I'm not happy with only prediction. I want to do something called as a prescription. Okay, so the knowledge can be classified into 4: descriptive knowledge, diagnostic knowledge, predictive knowledge, and prescriptive knowledge. So there are 4 types of knowledges. Descriptive is, you have a history. From the history, you understand something. Okay, the rains in Chennai have been very bad in the last 4 years. This is a description that I understand. Okay, now I try to find out what will be the type of rainfall in the year 2022. I'm trying to do a prediction. Okay, and I ran diagnostics. So the brain cells show this kind of a pattern. So what will be the type of a disease in the next picture? So this is something called as diagnostics. Okay, and the last one is called as prescription.
Is the slide moving?
No, sir, we are not moving. No, sir, I'm not moving the slide. I'm not moving the slide. Okay, and then we are looking at something called as prescriptive knowledge, where you want the problem to be identified and also the solution to be identified. Whereas this is where we start using our reinforcement algorithms. Okay, so there are 2 different perspectives of machine learning. One, people say that all these terms that we spoke so far are completely different. Statistical inference is completely different, machine learning is completely different, pattern recognition is different, and data mining is different, because they have applications on different fields and on different types of data. But there is another perspective where people say that all of them are almost one and the same. Okay, basically statistical inference is making decisions based on mathematical form models or empirical models. Okay, machine learning is more of heuristics. You are not only bothered about the end result, okay, you're also bothered about getting your optimized result. Okay, so you apply a lot of heuristics here. And pattern recognition is to identify similarities. Okay, and the data mining days have gone where people understand data warehousing and data mining as two separate topics. Now, when we talk about data mining, we start discussing from data collection, data pre-processing, cleaning, transformation, integration, etc. So we start from data collection to data visualization when we start talking about data mining. Now, to logically understand, all these are part and parcel of all our machine learning algorithms. If you understand them, they are almost one and the same.
Is connection lost?
Sir, it said I was removed from the meeting. Sorry. Am I audible still?
Yes, very much.
Yes, ma'am. Yes, sir. Thank you. Okay. So, where do we apply machine learning algorithms? Where does this requirement of a machine learning algorithm come to place? Okay. Say, for example, I have a repetitive mathematical task. I want to find out the power of 1, 2, 3, 4, 5, 6 to the power of 1, 2, 3, 4, 5, 6. This is a very repetitive, redundant, empirical formula-based task. If I have a human being perform this task, it might take even hours or days of computing. Okay. Now we have a lot of supercomputers and high computing machines available. For these computing machines, the time taken to perform this task may be less than nanoseconds or less than microseconds, something of that value or something of that scale. Okay. So when we have so much of computing power, why are we bothered about something called as machine learning? It is because machine learning algorithms come into play when we start thinking more about perceptive cognitive tasks. Okay, say for example, I want to control a manufacturing process. Okay, or I want to do a drug analysis or an astronomic discovery or something like this, where just the knowledge of a human expert will not be enough. Okay, you need a human expertise where the expertise is complex to be described and it is still repetitive. So in that case, we start applying our machine learning algorithms where they tend to give us better results. Two, when you have a black box human expertise. See, I see somebody 10 years back, okay, and I see the same person today morning, I can easily recognize. Now, if you ask me, there can be lot of changes on the facial features, but still I recognize the person. And if you ask me to put everything as a formula, I will not be able to do so. Or if you ask me to describe, how did you find out that it is the same person? I may not be able to describe it in certain set of parameters, but still this is a complex black box human expertise that I as a human being have. So when you want to mimic such black box human expertise, okay, machine learning algorithms tend to serve better. So we are talking about self-parking cars. We are talking about self-driving cars. We are talking about fault-tolerant planes. We are talking about driving ships, crews, and so on. Okay. Then when there is a rapidly changing phenomena, when you have lot of parameters to consider in a decision-making process, okay, then the human expertise or the human knowledge may not be enough. So there is a place where we start using our machine learning algorithms. And now the most important thing which is coming up in the industry, or which is making the most of the business, is customization or personalization. Now we have personalized marketing being done. We have customized recommendation systems which is done. We have recommendation systems. Either you start using your Swiggy, your Zomato, or your Dunzo, or your Zepto, or your Netflix, or your Amazon, or whatever it is. The moment you start ordering some type of food in Swiggy and you don't order for the next 1 week, immediately you start getting recommendations saying, see, there is a new outlet which has come up. There is food which is available. There is 50% off, something or the other. Okay. And it is, if you closely watch, it is all a customized advertisement which is done to you. And it is not that a large group of people will be getting the same advertisement. Similarly, when you start searching for a mobile phone, or when you start searching for a property, immediately you have suggestions about or recommendations about accessories of a mobile phone, or accessory or possibilities of loan. Okay, all this. So these are customized or personalized recommendations which are given to customers. The current survey says that 70% of the global business is driven by such customized marketing and personalized marketing, and thanks to this word, machine learning. Okay, so anybody who's on internet, okay, anybody who's using any smart device, okay, is giving away his or her own privacy or personal information or personal behavioral information, knowingly or unknowingly, to the internet. So there is a lot of knowledge generation which is being done. There is a lot of knowledge survey which is being done. So machine learning is there everywhere. So when we start talking about Google cars, or Tesla cars, okay, or the first versions of Alvin cars, okay, and all the social media applications, your web search results. If I search, say for example, I'm a foodie and I search for an apple, I will definitely get outputs, or I will get references about only an apple fruit. If there is a tech savvy person who searches about an apple, he will definitely get outcomes or outputs only related to the Apple phone or Apple systems. The web search results are that specific and that efficient based on the behavioral customized recommendation. Okay, and a lot of fraud detection happens because of machine learning. A lot of pattern recognition algorithms, either in medical or in any computer vision algorithms, apply machine learning algorithms. As I told you, all online recommendations, predictions, market pricing policies, all these are fields which use machine learning to a very larger extent. Okay, one fascinating thing about internet is, as I told you when we started our discussion, way back in 20-30 years back, okay, internet was still booming. So at that time, if there has to be an information which is to be sent to so many people, it would take time. So this is one example. So it took 75 years for people to start using telephones. Okay, and it took 38 years for radio, 13 years for television, and for people to use internet, understand what is internet and start using internet, it took 4 years. For Facebook, it just took 19 months. Okay, Pokemon Go is the most favorite game of people who are using internet. It just took 19 days. Now, this Arogya Setu app, which was released by the Indian government during the period of COVID, it just took 13 days to reach 50 million users globally. So that this is one example which says that every content which comes up on the internet, okay, spreads out so faster, and there is a lot of data collection and data supply which is happening over the internet. So this app was a primitive artificial intelligence machine learning algorithm, and it was using a simple Bluetooth technology to find out the proximity of users. Okay, so that was the technology used in this app. Okay, so we were talking about learning systems. So when I look for designing a learning system, what should I be doing? I should be finding out the right experience of training. Okay, so we talk about something called as the training data set, testing data set, and all that. So once my training data set has got all the veracity, all the variety, okay, and all velocity which represents the original problem, then my output model will be the best. Okay, so it all depends on the type of training you perform, the type of target function that you are looking forward, and the algorithm that you select for the learning purpose. So every learning system's important components are these. So any machine learning algorithm, this is the workflow. Okay, you collect a lot of data about the current domain. Okay, so when you collect all this data, you do your cleaning, preparing, and manipulating. This we call as the ETL process: extract, transform, and load. So when you extract your data can be of different formats, different data types, okay, different structures. Sometimes it can be unstructured, sometimes it can be structured, or sometimes it can be semi-structured. So you convert everything into a common structure. You clean your data, you synthesize your data, or you prepare your data. So there can be redundant values, there can be missing values. So you impute your data, you perform all the pre-processing tasks. Now, basically, this is part of data mining and data warehousing. Okay, so we have tools like Informatica and so on, which help us in this part. So you prepare your data, and this step is very, very important for efficient model generation. Okay, so once the data is prepared, you give it to a training model. Okay. Now, what is the difference between a traditional algorithm and a machine learning algorithm is, in a traditional algorithm, you give inputs, you write a program which implements an algorithm of using the input and giving you an output, giving you an expected output. But in a machine learning algorithm, you write a program which can deploy various other machine learning algorithms or machine learning algorithms customized for a given output. Okay, so that is the difference between a normal learning algorithm or a traditional learning algorithm and a machine learning algorithm. So here the machine tries to build models from the given data. Now days are gone that we started talking about model based learning. Now we also have something called as model free learning. Okay, in machine learning we were initially talking about supervised learning models, unsupervised learning models, semi-supervised learning models. Now people have started talking about model free learning. You don't have a model being fit already, but it is based on every new data which comes in. The system learns iteratively, the system learns incrementally. So now we have something called as model free learning, which is into discussion or which is into the field. Okay, so once you train your model, you test your model on the test data, you validate your data, and then you try to improvise. So whenever we talk about improvising is where we talk about our learning factor, our discounting factor, and so many other things. And the system keeps learning. Okay, every time, every iteration, it learns. But you want to understand how much is it learning. Is it learning positively or is it learning negatively? And this you want to provide back into the system as a feedback so that the system improvises the learning every time. Okay, so this is the generic workflow of any machine learning algorithm for that instance. Okay, so machine learning is basically classified into three types: supervised, unsupervised, and reinforcement learning algorithm. You do have another classification which is called a semi-supervised, but when we largely categorize them, we don't put them as a separate classification. Okay, we say that you find out a midway between supervised and unsupervised algorithm based on the requirement. So it is a requirement-based algorithm which is being defined. Okay, so what is supervised? Supervised is task-driven, or you have an idea of what you're looking for. So you have a labeled output and you're looking for a labeled output. Okay, just like you train your child at home showing a lot of pictures and you want the child to name the picture correctly. So that is called a supervised learning. Can you please unmute? Can you please mute the other participants? Yes, sir. Thank you. Okay, so the next one is called as unsupervised learning, where there is no kind of an expectation or a labeling related to the data. Okay, it is completely data driven. You provide some chunk of data to the system and you allow the system to understand, analyze, and come out with its own model or its own classification or clustering of data. So this is called as unsupervised learning. And the third most important task is called as the reinforcement learning. Reinforcement learning is otherwise also called the learning by mistakes or learning by rewards. Okay, or in management you call this as the carrot and stick principle of learning. So the system incrementally learns or iteratively learns step by step. Every iteration it learns. So it tries to understand what is good, what is bad, and learns based on this. So that is called as reinforcement learning. We will see everything, each and one in a little detail. So when I say supervised learning, I have a function which maps to a given output. I know what is my input. I have a function which works on the input, and I have an expectation on the output, and I look forward to get that expected output. Okay, so this we called as the labeled inputs. Okay, the example that I gave you or the analogy that I gave you, you train your child at home, showing it the pictures of various fruits and animals. And after learning, you want the child to name the fruits and animals correctly. So if you show an apple's picture, you want it to name it as an apple. So this is called a supervised learning. And whenever the child makes a mistake, you say, no, it is not correct. This is the right word. Okay. So this is a hand-holding done throughout the training process and throughout the testing process. So if you enable a system to learn using this policy, then you call it as supervised learning. So there are various algorithms which fall into the category of supervised learning, which is decision trees, support vector machines, naive-based classifiers, k nearest neighbors, etc. So in supervised learning, so this is how, sorry, this is how I can pictorially put content together. So I have a lot amount of raw data. Okay, I convert the data into a synthesized data. I start my training. I build my algorithm, and once my algorithm is built, I find out whether the algorithm behaves the same way on the set of test data. After the verification, I start implementing or deploying the model. Okay, so here the most important point is we have something called as a label. Okay, so labels are attached with every training data, and you also look for an expected label. So what is unsupervised learning? You don't have labels, that's all. It's exactly the same picture, but you don't have labels. So you allow the model or the algorithm to come out with a sensible knowledge of the data. Okay, and cluster or group the data based on it. So clustering algorithms, all associative learning algorithms come under the unsupervised learning methodologies. Okay, and the third type, okay, a midway between supervised and unsupervised is called as semi-supervised learning. So when do we use the semi-supervised learning algorithms? You want the system to classify based on its own analysis, but you want to fine-tune the classification, or you want to improvise the categorization done. Then you go in for something called a semi-supervised learning algorithm. One best example of the semi-supervised learning algorithm is the Google Expander. Okay, you start typing something on the search, Google search. You start with something, the remaining half of the sentence pops up. Now, when the remaining half of the sentence pops up, it is not just one sentence which comes. You will have some series of sentences, and you are allowed to select one out of them. Okay, so that is a semi-supervised learning algorithm. It is an application of a semi-supervised learning algorithm. So the algorithm which helps is a transductive support vector machine. So in an unsupervised learning algorithm, you have a lot of training data. The system tries to identify the features by itself. Okay, it does feature selection and feature identification. It identifies some similarities on the set of data that is given. It identifies patterns, and based on the patterns, it classifies or groups the data into certain clusters. So this is what an unsupervised learning algorithm, how a unsupervised learning algorithm works. Okay. When we talk about semi-supervised, it is midway between the two. It starts with unsupervised learning. Okay, you allow the model or you allow the training to happen on its own. The algorithm tries to get or derive sensible outcomes from the given data, and after the sensible outcomes are attained, you want to improvise the outcomes, you want to improvise the classification, you want to improvise the output. In that case, you move on to something called as supervised learning, or you feed it with some labeling. So there it becomes semi-supervised learning algorithm. So we use the semi-supervised algorithms mostly in speech analysis, protein sequencing, web content analysis, and so on. See, say for example, web content analysis, you give lot of web content which is available. It analyzes and it classifies into sports data, politics data, okay, entertainment data, and so on. So in the entertainment, you again have a lot of classifications. You have fashion related, you have series related, you have movies related. So there you add your labels. Okay, you add your labels, and you try to fine tune your clustering, or you fine tune your classification, okay, or a grouping. So this is semi-supervised learning algorithm. Okay, application of a semi-supervised learning algorithm. Okay, then comes a very interesting learning algorithm which is called as the reinforcement algorithm. Okay, so far when we talk about supervised, unsupervised, and semi-supervised learning algorithm, we are talking mostly about something called as model-based algorithm. Okay, when I say artificial intelligence, I want my machine to act, to behave like a human being, to think like a human being, to analyze like a human being, to provide decisions like a human being. Okay, so in an artificial intelligence system, as I told you, the system is allowed to build models. Okay, when there is an input, when there is a set of inputs given, depending on the inputs, depending on the description of knowledge which is obtained, the system starts building models. Okay, it either fits a clustering model, or a classification model, or a regression model, or any other type of model. Okay, now whenever you can, whenever sir, can you please mute the the other participant from where I get this noise. Sorry. Sir, I hope somebody's mic is unmute.
1 minute, madam. 1 minute, madam. I'll do it.
Okay, sir. No problem, sir.
Madam, you please carry on.
Okay, sir. Thank you so much, sir. Thank you, sir. Okay, so we were talking about model-based knowledge or model-based building of artificial intelligence algorithms or machine learning algorithms. Okay, but now we have moved on to something called as model-free artificial intelligence or model-free machine learning algorithms. And so far, when we are talking about supervised learning or unsupervised learning or semi-supervised learning, we were also talking about some fixed, descriptive, discriminant, empirical models. Okay, we were relying on certain mathematics, we were relying on certain statistics. Now we want to also include certain fuzziness. I am not happy with the decision making which happens only based on certain mathematical functions or certain formulas or based on certain rules, certain associative rules. Okay, now the knowledge has to be really human. Okay, so the knowledge has to have some amount of fuzziness into it, some amount of unpredictable knowledge has to be there, unpredictable learning has to be there. And I don't want the learning happen only during the training. I want the learning to be a continuous process. So in that case, using a supervised or an unsupervised or semi-supervised learning algorithm is not enough. So this is where we move into something called as reinforcement learning, or I would name it as a very human-like learning. Okay, reinforcement learning is more of a human-like learning. Okay, also an additional information is there are three versions or three groups or three versions of artificial intelligence. The first version or the first generation is called as the general artificial intelligence. So when people started building robots to move inside a maze, or when people started building Atari games, or when people started building AlphaGo, okay, when people started building chess, automated chess playing games, all these were based on set of databases. You provide entire knowledge to the system. You say these are the possible moves. Okay, this is how you have to play the game, and the system responds to the given input. This is called general intelligence. Okay, so way back in 1960, we were talking about artificial intelligence. So from that era, we still have general intelligence. Now we have moved on to something called as narrow artificial intelligence, wherein we are now targeting on specific behavior of customers, specific behavior of systems, or specific recommender systems. So this is called as narrow artificial intelligence. So all this while, when we started working on general artificial intelligence or narrow artificial intelligence, our supervised, unsupervised, and semi-supervised algorithms did help us a lot. But now we want to move into something called a super artificial intelligence. So what is the super artificial intelligence? Actually, something like a miracle. Okay, everything automatically done by a machine. Okay, a machine completely thinks like a human being or even more than a human being. So that is called a super artificial intelligence. So your Tesla car, which is going to be coming, okay, will be the first, will be one of the primitive super artificial intelligence systems. The humanoid robots, okay, Sophia and others, those are the updated versions or the better versions in narrow artificial intelligence. They have not even started with super artificial intelligence systems. So with the amount of technology improvement and with the amount of research which is going on in the field of artificial intelligence, it is predicted that maybe in another decade, we will start working on something called as super artificial intelligence. Okay, so the big thing is still coming. Okay, so when we have to move into this field of super artificial intelligence, reinforcement learning is going to be the answer. So all of us have to start moving into this content of reinforcement learning to move in or improve our research on artificial intelligence. So what is this reinforcement learning? The reinforcement learning is situational learning or scenario based learning or learning by rewards, or learning by punishments. You have so many names which are added to this. So what happens here? We have an agent. So the agent is the system that I'm talking about. And you have an environment. The environment is the surrounding of the agent. Okay. And every time the agent is going to perform a task. Based on the action that the agent performs, the environment will change. Okay. The environment will either do a state change and give a reward, or will do a state change and provide a punishment. Okay. So based on what the environment rewards are based on the environment punishments, the agent will understand, okay, I'm learning the right way or I'm learning the wrong way. So it changes the way it learns. Okay. Sounds to be very human. So that's why I called this as very human-like learning. Okay. Let me put this as a very, very simple example. Say we have a toddler, we have children at home. Okay. Say, for example, the children have been observing us, okay, for a very long time using a TV. So my child is my agent now, and the TV is my environment. Okay. And the child has now observed that there is something called as remote or some device, some handheld device. People start pressing something on the device and the TV changes. Okay. The channels change. Okay. So the agent, which is the child, will start pressing various buttons on the remote, which is the action performed. Now, based on the button performed, okay, you have a change in the channel, which is a state change. Okay. If the channel that the child wants to view comes up, it is a reward. If the channel which the child does not want to view comes up, it is called as a punishment. Okay. Okay. Just a minute. Okay, which comes in, it's called as a punishment. So based on, say for example, the first time when the child starts using the remote, it might use 8 or 9 attempts to press the correct cartoon channel. The next time it might use only 5 or 6 attempts. The third time it will be only 2 or 3 attempts. The last time it will directly come and press only that button in which it has got the cartoon channel put up. So that is the type of learning that it has. So it is a positive feedback. Every time the child learns based on the positive feedback. Negative feedback, by the same time, it has also learned that, okay, if I start pressing some other buttons, there are channels which I'm not interested looking at. Okay, so it understands this also, and this is a negative feedback based on which the child learns. Okay, so there is positive reinforcement or negative reinforcement based on which the child learns. So it can either be reward or a negative reward. Punishment is sometimes by mistake the child presses the power off button, okay, and it does not know how to put it on. This is called as a punishment feedback. Okay, so the second or third time when the child starts using the remote, it will be very, very sure that it never presses the power button. Okay, so this is also a learning that the child learns. Okay, so these are the 3 types of learning in reinforcement learning methodology, which enables a system to start acting more like human beings. Okay, so this is where we start talking about our deep learning systems, okay, deep learning algorithms and so on. But the major constraint that is not helping people to move progress forward in the field of artificial intelligence is we have something called as the extinction learning. This we also call as the learning curve, okay, in management. Okay, when somebody starts learning, the learning happens at a higher speed, but after a period of time, the learning does not change. Similarly here, the child may lose interest on a TV very soon. Okay, maybe it watches for a period of say a few weeks or few months, after which the child is never interested in watching a TV. So this is called as an extinction learning. So even after a lot of iterations, there are possibilities that the system ends up in a situation where there is no considerable change in the output. Okay, so this is called as extinction learning. Whenever we work on the field of reinforcement learning, because extinction learning is possible, there is very less improvement or very less progress happening. Okay, so this is the diagrammatic or schematic representation of reinforcement learning. Same here, you collect all your raw data, you process your data, you train your model. When you build your model, you make sure that the model always gets a feedback. As a closed system, gets a feedback where the feedback can be either a punishment or a reward. So you add some kind of a metric, okay, something called as a learning factor or a discounting factor, some numerical value is added along with the algorithm, which is positively increased when the learning happens and positively and it is negatively decreased when the learning is negative. Okay, certain algorithms which help you in this reinforcement learning is Q-learning algorithm and SARSA algorithm. Most of the models that are being built use only Q-learning algorithm. Okay, so when I take up the machine learning perspective at large, okay, when I want to see the big picture, I can classify all the machine learning algorithms into these three types. Okay, supervised, unsupervised, and reinforcement learning. But in supervised learning, okay, whenever I have a problem of classification or regression, okay, I will be using my supervised learning algorithms. Whenever I have a problem of clustering or dimensionality reduction, I will be using unsupervised learning algorithm. Okay, whenever I want to think more like a human being, improve iterative tasks, okay, improve progressively incremental tasks like your gaming AI, robo navigation, real-time decisions, I will be working on reinforcement learning. So these are the major classifications or the major areas of machine learning applications. Okay, so we know in supervised learning, whenever it is prediction, classification, and regression, we use supervised learning algorithms. Whenever it is clustering, distribution estimation, association, dimensionality reduction, it is unsupervised learning algorithm. Now, one interesting field is this dimensionality reduction. I want to do a prediction. I want to work on, or I want to generate some knowledge from the given data. Should I be accommodating all the dimensions of the data, or can I make the system less complex by reducing the amount of dimensions? This is one open discussion which is still under an area of research. So if there are researchers here, this is one area. So there are a lot of researchers which are going on into concepts of linear discriminant analysis, principal component analysis, to identify which are those important dimensions which can be used for machine learning models. Okay, say I have 50 parameters. Say if I want to find out somebody has cancer, okay, I'll have to take height, weight, age, the person's history, but the person's eating habit, X, Y, Z. Okay, so if I have more number of parameters, the prediction can be tougher. But if I reduce it to say 3 or 4 parameters, then my problem solving becomes easier. So I want to do this. This is called as dimensionality reduction. Okay, so there are a number of methods. Okay, principal component analysis and linear component analysis, linear discriminant analysis are the most famous methods or most widely used methodologies. Okay, next is semi-supervised and reinforcement learning algorithm. Okay, so when I say classification, I am trying to group data based on labels. Okay, so say classify into 2 groups or put them into A or B class, something like that. Okay, regression mostly whenever I have a continuous input data and whenever I want to do prediction. Okay, so whenever I want to do a numerical classification and I have to do a prediction, I go in for regression models. Association is when I want to find out an associativity on the given input and then define my model. Okay, the most widely used example is the a priori algorithm, which we call as the market basket analysis. Okay, as a marketing person, I want to identify what are those products which are very closely related to customers. Okay, which will they buy? You know, sometimes there are discounts coming in with 2 products together. Okay, just because there is a discount, you will buy the product. Okay, and when you walk into a supermarket, sometimes you see that chips and Pepsi bottles are put together. Okay, and they say that it comes with a reduced price. Okay, or you take this, you get the other one free. These are all results of applying these association algorithms. They try to find out what is the customer behavior of buying and what is the association of various products, how products can go together, and based on that, they model their entire business pricing model, entire business selling models. Okay, so that is one place where association algorithms play a major role. Okay, similarly, when you want to forecast, okay, your Sensex data, you use association. Okay, then is the clustering algorithm. So when you want to group, you use your clustering algorithms, and there are a number of types of clustering: K-means clustering, DB-scan, hierarchical clustering, where you have agglomerative clustering, divisive clustering, and so on. Okay, so this is my entire, we have been talking about so much. So if I have to put everything into one picture, this is how I'll put it. Okay, I collect my data, then I process my data. Once I process my data, I start identifying the important features. So I extract the features from the model, from the given data, and I rank them. There can be n number of features, but I want to find out which one is very important. Say, for example, I want to predict cancer because in lungs. Okay, then I have number of features. Say I take whether I try to find out whether the person is obese. I try to find out whether the person has BP. I try to find out whether the person has good eating habits. All that. Okay, all these features. But which will be the most important feature? Is a smoking habit or is alcohol habit. Okay, so I have number of features which can be used in the decision making process. Okay, which I have extracted from the knowledge of the domain, but I try to rank them, and based on that I start building my model. So the model first learns from the data and then starts evaluating from it. Okay, once the evaluation is acceptable, we start moving on to something called as the model deployment. Okay, you start building the real model. Okay, so training is very important. So when you do your training, you want your system to learn about all types of data. Okay, you want your system to learn all types of data. Only then the system will respond to a real-time situation properly. Say, for example, I want to, in a class of say 60 or 70, I want to find out good students and bad students. And if I build my system giving input only as good students, okay, the system will never know something called as bad students at all. So if you provide this bad students data during the testing phase, it will give you an error, or it might not give you a proper classification. A simple example, that's all. So when you provide training, you have to train with large amount of data and large variety of data and large possibilities of outcomes of data. Okay, only then the training will be the best. Okay, so this is what we call as the no free lunch rule, or simply to say no pain no gain. That's all. This is called as no free lunch rule. Okay, only when you take pain of including large amounts of data, large varieties of data, you get a good output. Okay, so this is what we call as the no free lunch rule. Okay, you don't make any assumptions. You don't assume that the system will work like this. You don't make any bias so that the system either goes to an overfitting or an underfitting state. You provide the right amount of data and the right mix of data for the system to learn. Okay, so when I say training, when I say building models, performance of the model is very, very important. Okay, there are only two important factors. What model do you use, and whether the model is an optimized model. Okay, whether the model is going to give you the best result. So these two are based on the type of training you provide, the amount of data that you have collected for the training, okay, the type of feedback system that you are going to use in the system, and the algorithm that you use. So the performance of any machine learning model that you build, okay, is based on these four factors. Okay, so machine learning is not a completely new dimension or a paradigm shift which has come into the technology. Okay, people have been talking about machine learning in different names in different periods. Okay, people were talking about neural networks. Okay, we have learned about neural networks way back in 1995. Okay, from 1995, this concept of neural networks is in place. Okay, we have learned about something called as case-based learning. We have learned about something called as genetic algorithms, rule induction. Okay, where you apply all your search algorithms, but you don't just look for an output, you look for the best output at the best situation, meaning applying heuristics. Okay, and we also look for we have also learned about analytic methods. So when I say ML, okay, or machine learning in the real world has got different names. Either you work on neural network or case-based listening or genetic algorithm. Finally, everything is related to machine learning, because you system to learn by itself or act like a human being learning by itself. Okay, but the names differ, the notations differ. That's all. Okay, so there are different varieties of machine learning used in different fields. Okay, whenever you take up any domain of knowledge or any domain of education, you have at least one of these types of learning applied. Okay, some places we call this as concept learning. Okay, people working in the fashion industry, media industry, they call this as concept learning. Okay, people working on computer science, they call this as clustering algorithms, genetic algorithms. People working on okay, the bioinformatics, they call this as genetic algorithms, explanation-based algorithms. Okay, cognitive learning architectures. Okay, people working on mechanical, they call it this as transformation-based learning, explanation-based learning. Okay, so all these are different terms of the same picture or different terms of the same knowledge. Okay, finally at the end of the day, we are talking about machine learning. Whatever term we use, whatever terminology we use, we are only talking about one particular dimension of machine learning. Okay, so learning, you can apply it for a black box learning methodology. You can apply when there is a transparent, understandable knowledge requirement. Okay, when there is a instance-based or a case-based reasoning. Okay, black box and transparent box, I would call it as model-based learning. Instant-based and case-based learning, I will call it as model-free learning. Okay. Okay, so these are the various machine learning applications. Okay, you can use machine learning algorithms for all of these. Okay, we have already had a quick look at all of them. Okay, online customer support, video surveillance. Okay, in traffic signals, you want to find out who does not obey the traffic. In railway stations, you want to find out any anonymous activity. Okay, you have your Google Translator, which is an example, which is a fantastic example of reinforcement learning algorithm. Okay, it is both unsupervised and it is a reinforcement learning algorithm. All of us are using virtual personal assistants. Many of us at home. Okay, we are using our VPAs in our phones. Okay, handheld devices. So all these are into the market because of machine learning. Okay, machine learning is the one which is acting behind. Okay, so we were talking to find out certain day-to-day examples of where machine learning is being used. Okay, so the one very fascinating example that I use or I generally tell people is the use of robots in supermarkets. Okay, Walmart uses robots in its supermarket, which is of 2,400 square meters. I'm not talking about square feet. It is 2,400 square meters of place, wherein there are only 2 robots. Okay, which does the entire inventory management, packing, and pricing. Okay, sometimes there is even only 1 robot. You see this bot. This bot scans all the aisles every day twice, and it identifies what is the inventory which is missing, what has to be refilled. Okay, any online order comes, it packs, it does the price checking, it does everything. Human intervention happens only during the delivery of the product. And right now there are a number of automated robots which are coming in, which are also used for delivery. All of us would be watching TV during the COVID. Okay, there were use of robots to a larger extent, where robots were used to deliver products. Okay, deliver products to different patients, different customers in a fixed geographical location. So there are a lot of researchers which are going on to use robots completely. So maybe in another 10 years or 5 or 10 years, instead of a Swiggy person who is coming and delivering as a product, there can be a robot who is coming and knocking our door. Okay, this can happen. Okay, these in the large application in the manufacturing industry, say in car manufacturing, Tesla is not automating. It is all manual. It is because every car product is of different size. So you want a human being in the right place when you go in for the assembling of cars. Even Tesla cars, we are talking intervention. But now Tesla is also working on the second half of it, where they are trying to build robots which can handle products of objects of different sizes correctly. Okay, so they are trying to replace human being even in the assembling stage. Everything else is automated. They want to replace human beings even at the assembly stage. Okay, so that is an example of machine learning. Okay, now we have robots and who can act as chefs and waiters. Okay, I heard that there is one restaurant in Mumbai which has a robot chef. Okay, you give the order. Okay, the robot will know what is your taste. Okay, what is the type of food you like, and whether you have BP, sugar, all that is already known by the robot because you have your Aadhaar card details. Okay, and because your medical history, everything is available. It cooks the food as per your taste and delivers it to you. So that's the amount of machine learning which is being used. And I hope every one of us will be using Uber, Rapido, Ola, and all these services. All these services are completely dependent on an exhaustive machine learning algorithm. Okay, the example that I'm showing you now is the Uber's example. Uber uses self-built internal ML platform, which is called as the Michelangelo. So that is used for identifying demand and suggest prices. So Uber is extensively using this machine learning algorithm. Okay, now, most of us will be using Spotify. Okay, a lot of music apps now. So all these music recommendations based on your moods and interest. Okay, they have machine learning algorithm which is running behind. Okay, Thomson routers, because all of us are researchers. We know that our Scopus index is important, our Web of Science index is important, our H index is important. All this calculation is done based on a machine learning algorithm. So Tamil is one data acquisition model, okay, which collects data across all the indexed publications, and it is unified and given and it is uploaded in Thomson Reuters, okay, because you do publications in different citation index in different journals, okay, based on the authorship, based on the type of viewership, based on the citation, okay. Tamar is one which adds it to Thomson Reuters, okay. And in the field of medicine, we are talking about specific medicines for children, okay. It is not one vaccine for all, okay. Now people are working on content specific or customer specific vaccines, okay. Vaccine which is specific only for a target group, okay. So GlaxoSmithKline is working on this product, okay. These are just examples. And the one most important machine learning application which took the entire marketing industry by storm is the Amazon Go. I think most of you would have watched the video of Amazon Go in YouTube. It was viral maybe 3-4 years back or 5 years back, okay. The customer walks into the shop, picks up his own product and comes out of the shop. There is no billing, there is no line, there is no checkout, there is nothing, okay. Everything is by the scan of the product code, okay, QR code, okay. So this is one very important application of Amazon. Amazon topped all the other markets, even crossed Walmart based on this application. It's due to this application, okay. Do we use machine learning only in computer science, only in medicine? No. Only in mechanical? No. We do apply it in civil engineering also, okay. Whenever you want to design a construction management system, whenever you want to plan roads, whenever you want to do a transportation prediction, okay, arrivals of buses, okay, you want to schedule the arrival of buses, whenever you want to do any geospatial engineering applications, okay, everywhere we have machine learning algorithms play a major role, okay. So as we spoke about mechanical engineering, okay, building automated cars, okay, is all dependent on IoT devices, big data analytics. You're trying to find out methodologies of manufacturing control, manufacturing reorganization, okay, doing root cause analysis. Why did this product fail? What happened? So all this is based on machine learning algorithms. So the first automated car looked like this. This is Alvin. Okay, so this is the first version of the automated car. Then came Google cars and Tesla cars and all that. Okay, this is the first car. Now, if you can see, you have every external device hard mounted on the car. Okay, everything, autopilot system, your lidar, sensor, okay, your camera, everything was mounted on the car. Okay, later slowly it started. We started putting it, embedding it into the car. Okay, so this is the second version. Okay, so the first version looked like this. So data was collected, and there was a machine learning component. There was a hardware, separate computing hardware, which was included into the car, and which was doing all the computation purpose. Now everything comes as single onboard entity now. Okay, not autonomous cars. Everything comes as one single onboard entity. Now we are not only talking about autonomous driving cars. We are also talking about self-parking cars. Okay, even Toyota cars, the high-end Toyota cars have got self-parking facility, which is an added advantage, which is an advantage because of machine learning algorithms. Similarly, on highways, okay, these adaptive cruise control is used in a lot of Western countries. Okay, because on the highways, cars sped in a very high speed. Okay, so they want to identify the near proximity of other vehicles to avoid accidents. So this is one application which is because of machine learning. Okay, similarly, adaptive high beams. Okay, you increase the headlamp range and the distance based on the type of movement of the cars on the road. Okay, it is also an application of machine learning. Okay, in mechanics, again, you can find out mechanical failures. You can do continuous monitoring of data, continuous industrial application monitoring. Okay, you can do a lot of predictive maintenance, which will reduce the cost of running a business. Okay, all these are easy, have become easy because of the application of machine learning. Okay, and in the field of medicine, okay, machine learning has actually brought in a lot of change in the field of machine learning. Okay, now an operation is possible, a surgery is possible with a doctor geographically located at a different location, patient in a different location, doctor at a different location, still performing an invasive surgery. Okay, with by use of an artificial intelligence system. Okay, you have robots which perform the entire surgery, taking guidance or taking inputs from a doctor, from an expert who is connected through a video conference from a different distance location. So all this is possible because of the technology advancement in machine learning. Okay, so you have MRI brain scans, better identification of diseases, better treatment policies, better monitoring of tumors. All this is possible because of machine learning. Okay, now one interesting component or one interesting facet of internet which has come up is the chatbots. You log into any college website or university website, there is a chatbot which pops up. Okay, you log into any shopping website, a chatbot pops up. It says, what do you want? Can I be of service? Okay, what are you looking at? So when you start answering, you're actually giving a lot of your data to the system. Okay, the system stores your data. Okay, starts analyzing your behavior and gives you future recommendations based on your input. So chatbots are one important value addition in the market chain. Okay, and these are also ways of adding more data to the available input behavioral information. Okay, so chatbots are another perspective where machine learning has got a wide variety of application. Okay, better chatbots can be built by better application of machine learning algorithms. Okay, all these chatbots are actually linked to many social media websites. Okay, so either you use a chatbot once and then log into any social website, you automatically get recommendations. So all this is possible because of machine learning algorithms. Okay, and Internet of Things. Okay, we are talking about smart devices. Okay, smart things, smart Fitbits. Okay, anybody sharing information from anywhere. Okay, any place, anywhere, any service, any business, anyone, anybody. So this any is connected to this Internet of Things. Okay, anything can share data, anything can give you information, anybody can share data. So with the Internet of Things coming into place, okay, your fridge is going to be a smart fridge. Okay, you need not go to the market and order for foods. Okay, the fridge, which is an automated smart device, is going to analyze your behavior, what kind of food you eat, what is the pattern of food you eat. Say for example, every Monday you have curd and you don't have curd on Sunday afternoon, it is going to automatically place your order. Okay, so that is the amount of machine learning which has come into our daily life. Okay, along with the use of Internet of Things. Okay, because we were talking about personalizations, okay, these are some examples of personalization. We have our Alexa. Okay, say for example, you buy an Alexa at home and you start playing your certain set of songs in the morning and certain set of songs in the evening. Okay, after a week, Alexa will automatically do it for you. Okay, I think most of us are using an Alexa at home. Similarly, your Google Assistant. Okay, your phone Google Assistants. All of us know about Sophia, a social humanoid. Okay, which acts very much like a human being, and this is one which is given a citizenship. Okay, because it acts more like a human being. So all this is possible because of machine learning algorithms working behind. So these are the various platforms which are used for these personalization content. Okay, IBM is doing a lot of work. All this data is available on this marketing cloud, which is called as the Salesforce. Okay, Qubit, Lytics, all these are companies which are coming out with wonderful machine learning algorithms and coming out with major personalization platforms. Okay, so when I take machine learning, okay, you have applications of machine learning almost in all industries. So I have given you a gist or a glimpse of most of them. Okay, either you take manufacturing, you use it for predictive maintenance, demand forecasting, optimization of product chain. Okay, if you take retail, you want to do inventory planning, you want to do prediction of your profits. Okay, customer return of investment, market segmentation, and all that. In healthcare, okay, you want to give better monitoring of diseases, better identification of diseases. Okay, you want to give better triage facilities to the patient. Okay, in travel and hospitality, you want to do aircraft scheduling, you want to do ship route scheduling. Okay, you want to do bus scheduling. Okay, you want to pass information or advertise information, publicize information on the media. Okay, you want to understand traffic patterns. Similarly, in financial services, you want to find out credit scores. Okay, you want to find out whether the person is a reliable person to give a loan. Okay, you want to find out the risk analysis. Okay, and energy and feedback. There are cities in the Western countries where the entire power supply is managed by a simple machine learning algorithm. They find out what kind of industries or what kind of localities need more power at what time. So depending on that, the entire scheduling of power generation and power supply is done. Okay, so which gives an optimized use of power, optimized use of energy. So machine learning has got application in all the industries. Okay, and with robotics coming up, okay, there is a lot of investment which is going into the field of robotics. Okay, we were talking about Sophia, which was a sorry, which was an important invention 2-3 years back. Okay, before in 2017 this humanoid robot came into existence, but now people have discarded Sophia, saying to be very, very primitive. They are trying to build robots which have got better facilities. Okay, so with amount of investment which is being pushed into the field of robotics, machine learning and artificial intelligence have got a wide area of growth, wide area to progress. So we have robotics in every area. Okay, either it is industrial services, military, healthcare, or experimental purposes. Okay, everywhere we have robots. So whenever I don't want a human being to be involved in a dangerous task or a repetitive task or a high precision task, definitely I will rely on a robot. Okay, we have automated rovers, okay, drones. Okay, all these are types of robots. Okay, so these are some examples, robo which are used in the manufacturing industry for every purpose. Okay, even for my automated packing, okay, and packaging, we use robots. Okay, instead of a human being doing a packaging, okay, some time back, now we are relying on robots which are involved in automated packaging. Okay, and robots have found a large progress in the field of military and government. It's because to identify mines, okay, to do stealth analysis. Okay, there are a lot of robots and drones which are used. Okay, this is where we use a lot of rover systems. Okay, so to identify landmines, so this is a robo example, okay, which is used to identify landmines. Okay, aerial drones, military suits, okay, unmanned vehicles, okay, unmanned vehicles, UAVs. All these are possible because of the use of artificial intelligence and machine learning. Okay, mostly machine learning. Okay, so in space technologies, okay, definitely these machine learning algorithms have got to play a major role because it is an automated system. One, and whenever there is a data which is being collected, you want the computing to be done there itself, and you want the data to be sent here. Okay, so machine learning algorithms play a major role. Okay, and you have a large interesting application of robots, which is the service robots. Now I have robots which can sweep my floor, which can mop my floor, okay, which can do all cleaning for me. Okay, UV radiation robots. Okay, whenever after this COVID, this UV radiation or scanning robots have taken the market by a storm. Okay, there are a lot of purchases of this UV radiation robots in the market, mostly in the Western countries and in China. Okay, it can automatically scan and sanitize the entire room. Okay, so that's called as the rehabilitation robots. And there are robots which can help people to recover from depression, from various diseases and so on. Okay, robots are used in surveillance. Okay, even lawn mowers, firefighters. Okay, search, rescue, everywhere. Okay, automatic picking of people who have fallen into a pit and all this. So all these are various service robots. Now, why are we talking about robots? It's because when I start talking about robots, I want the robots to not do a physical task, but to also have a computing power. And now this computing power comes due to a machine learning algorithm which is in place. Okay, as I told you, in healthcare, robots play a very, very major role. You have mind-controlled robots. Okay, there are people who have lost their physical parts like arms, legs, or some parts of their fingers and so on. So you can connect them to a prosthetic, and the prosthetic is completely managed by the sensors. Okay, or it can be mind controlled. Okay, it can be controlled by your brain waves. So all this is possible because of the machine learning algorithms or the artificial intelligence systems in place. Okay, you have simulated aircrafts running. It's all because of the application of machine learning and artificial intelligence. So these are some drug discovery applications, okay, test tube sorting and so on. Okay, throughout our discussion, I was talking about machine learning. Sometimes I was calling it as artificial intelligence sometimes. Why? Because both are invariably used. The big picture is artificial intelligence. Why? Because I want my machines to think like a human being and act like a human being. Okay, so for that I need my system to learn. How is it possible? By building algorithms which can be explicitly programmed to develop another model. So that is machine learning. And now I'm not happy with just the machine learning something. I want the machine to learn into a fine-grained level. Okay, I want the learning to happen at a higher degree of learning. I want to have a higher degree of learning. That is why I talk about deep learning. So whenever I start talking about reinforcement learning, neural networks, and all that, those are related fields to deep learning. Okay, so if I have to give you examples of applications which use deep learning, okay, AlphaGo, your natural speech recognitions, okay, your Waymo, all these are examples of deep learning. Okay. Okay, one picture which can give you an understanding of what deep learning is. So traditionally, we define all the features and we train our classifier. So based on the features, the classifier trains. Okay, trains itself and then classifies the objects. Now, when we started using machine learning, the extraction automatically happens and it identifies some more features and then it classifies. This is more of an unsupervised learning algorithm. And when we move into something called as deep learning, you try to understand more fine-grained details, or high level of precision is attained by using deep learning. Okay, so all that we discussed, if I have to put it in one slide, this is how the slide will look like. Okay, this is called as the machine intelligence landscape. Okay, if you are trying to think about core technologies, yes, you have machine learning in place. If you're thinking about futuristic technologies, you have machine learning in place. If you are thinking about assistive technologies, you have machine learning in place. If you are looking at high performance computing, you have machine learning in place. Okay, so you have machine learning touching almost every walk of the industry and every walk of life. Okay, either you talk about data preparation, data collection, hardware, agriculture, education, finance, HR, okay, intelligence, speech recognition, mechanics, so whatever it is, everywhere you have one or the other industry playing a major role. So this picture shows you a lot of examples of companies which are doing major research or major products in each of this subfields. Okay, say for example, Blue Driver is doing a great work in agriculture. Okay, we know all of us have been using Coursera, Udemy, okay, Newton, Edureka, all this in the field of education. Okay, in finance you have Bloomberg, okay, data miner. All this is working are bringing in a lot of changes in the field of finance. Okay, in legal you have Ravels. Okay, you have Lex Mechanica. All these are tools which are coming in. So all these are companies which are coming in with lot of tools. Okay, so this is one picture which can give you an overall idea of the amount of machine learning which is happening or which is touching our every day in and day out of life. So all of us are using one or the other product of this. Okay, so what is the future of machine learning? Okay, as I told you, when people start working on reinforcement learning, there are certain constraints. Okay, and there is a lot of research still to happen in the field of unsupervised learning algorithms. And as I told you, 70% of the market is driven by personalized marketing. So there can be more improvisations on personalizations. And people are talking about quantum computing now. Okay, so application of machine learning in the field of quantum computing is an open area, and a lot of cognitive services are still to be explored. Okay, there is already done, but we still have a lot of way to go in cognitive services. So to have improved cognitive services, we have machine learning to play a major role. And also, as we spoke about robots, when there is progress in robo technology, definitely machine learning algorithm is going to have a high upper hand. Okay, and any technology which comes into picture or any technology which comes into the market is based on Gartner's predictions. So Gartner's predictions shows that there is a lot more of innovation which is going to come in the field of AI, digital twins, cloud, and blockchain. Okay, people have started using a lot of intelligent things. Okay, and to machines to become intelligent, we need a lot of artificial intelligence and machine learning algorithms. We are talking about IoT and digital twins. Okay, and to store all this data, we need cloud. And whenever we talk about data, we also have to talk about a lot of security issues. So blockchain also comes into picture. So all these are the futuristic technologies which are going to come into the market in a long way. Okay, so these are the technology trends for the year 2022, specific technology trends by Gartner. So as a researcher or as a student, okay, I would tell you. So if you say, for example, you're planning to do a research, you're planning to register for a PhD, please refer to Gartner's trends. Okay, find out the Gartner's trends after 5 years. What will be the trend after 5 years? Gartner says there is going to be a lot of innovation which is going to come in composite AI, explainable AI. Okay, so start concentrating or start identifying problems in those fields rather than just selecting one problem, which is because people right now people are talking more about cloud, people are talking more about blockchain, people are talking more about IoT. I will select one problem from IoT. Don't do that. Okay, always look for Gartner's predictions. Find out the technology trend in the next 5 years, because when you start your research now, but after 4 or 5 years is when you are going to submit your research. So at that time, the research that you perform should not be into a stage of saturation, or should not have had already lot of explorations done, so that you are only reinventing the wheel. Okay, so always look for Gartner's predictions. You can just type Gartner's predictions or Gartner's technology predictions in Google and have strategic technology predictions, technical technology predictions, okay, financial predictions. All this is possible. So whatever field you're working on, try to see the Gartner predictions and then identify your field of research. That will be just one additional point that I wanted to stress on. So Gartner says you're going to have lot of accelerating growth in generative AI, autonomic systems. Okay, generative AI, autonomic systems, distributed enterprise, all this is inherently using machine learning. Okay, similarly, AI engineering, hyper automation, decision intelligence, again we are talking about only machine learning, which is going to play a major role. Okay, whenever I'm talking about privacy enhancing or cyber security, again there is some amount of machine learning which is playing a major role. So what machine learning is going to be one default subject or one default content which is going to touch any field of invention or technology advancement in the future. Okay, so now we have started talking about something called as Industry 4.0, and now even Industry 4.0 is not in the market. People have started talking about Society 5.0. Okay, so Industry 4.0 is nothing but a accumulation of all latest technologies of the future. Okay, like cognitive computing, cyber security, Internet of Things. Okay, mobile technologies, 3D printing. 3D printing, if you are from the mechanical field, 3D printing is going to go a long way. Okay, with the use of machine learning, you build models, you do your 3D printing, deploy the models, find out the changes which has to be updated, and again you start improvising your model. Okay, big data analytics and all that. So this is going to be the future of technology. Okay, so if I have to become a machine learning engineer, or if I have to become an AI engineer, okay, what are the skills that I have to look for? Okay, so I can either become a process or automation engineer, where I only deal about how the process works, okay, defining processes, okay, working on process automations, or I can become a data scientist, mostly concentrating on data mining, okay, data warehousing, tools to handle data, or I can become data engineer, talking about infrastructure which can be used on measuring the data. I can talk about information theory, okay, information retrieval, okay, data infrastructure, data architectures, and so on. Or I can actually become AI creation experts or translators, where I bring in the know-hows of training a model. Okay, we have so many models in place, and there are so many models which are still being developed. So you can become one AI creation expert where you build your own model. Okay, so there are various places where you can actually focus and start working on. Okay, so depending on where you're planning to work. Okay, so these are some software tools which you have to concentrate. So if you have just started working on Python, okay, or started working on machine learning, it's better you just concentrate on scikit-learn packages and PyTorch. Okay, this is more than enough to basically understand the ability of any machine learning algorithm to work on any simple classification, regression, clustering algorithms. These two are more than enough. But if you want to work on to move on to something called as reinforcement learning or deep learning, you'll have to start learning about TensorFlow and similarly Keras. There is something called as Keras. So you'll have to start learning more about Keras. Okay. If you are planning to work as a data scientist, then you have to start learning about VECA, okay, a Vacato environment, okay, where you only concentrate on how to prepare data, how to visualize data. When we talk about data visualization, you have Tableau. Okay, people say it's a very simple tool, but if you dig deep, you have a lot more of information which has to be learned from Tableau. Okay, if you are planning to work on large amounts of data, we were talking about data infrastructure. So in that case, you should be learning 9. Okay, to start with, again, Colab is one tool. Okay, you can it's a mediocre tool. Okay, you can be an expert or you can be a starter. You can still use Colab. Okay, if you are concentrating more on clustering and regression algorithms like logistic regression, SVMs, and all that, start concentrating on Apache or AcosNet. Okay, if you're using a lot of video data, audio data, or you're talking about unstructured data, then AcosNet is the one which will come handy. Okay, so start learning AcosNet. Okay, Shogun is also a very similar tool which is concentrating more on dimensionality reduction. Okay, data from social media. Okay, data from social media can be used, can be obtained by RapidMiner. Okay, this is also again a data scientist tool. Okay, and Oryx is another filtering tool, more of a data pre-processing tool. Oryx is mostly used for pre-processing rather than for actually for machine learning model building algorithms. Okay, so these are some software tools that you'll have to concentrate if you're planning to work on machine learning. So we've come to the end of the discussion. So throughout the discussion, we try to understand the big picture, what is artificial intelligence. Then we try to understand what is machine learning, various types of machine learning algorithms, applications of machine learning algorithms. So if you have to work in the field of machine learning, what is that you have to look for? What kind of tools that you have to learn for? And we just started with what is deep learning. Okay, deep learning is model-free learning. Okay, or learning incrementally. So that is what is called as deep learning. Okay, so if you are a person who says that I don't know any of these, then this is the right time that you start learning. It's because these are going to be the watchwords of the market in the next few decades. Okay, so if you don't learn, then you are not part of the market. Either you are an educationist or a software professional or a student or whoever you are, you have to know these words. Okay, you cannot just say that I'm a mechanical engineer or I'm a bioinformatics engineer or I'm a civil engineer. Any field, I have shown you examples from almost all the fields. Okay, any field you're working on, you definitely need the knowledge of artificial intelligence and machine learning to stay in the industry. Okay. Okay, so I would wind up here. If you have any questions, I'm open to take questions now.
Yeah. Thank you very much, madam. Let us ask the. It is a very nice presentation, madam. Thank you very much. We will ask the participants if they are having any questions. Let them ask.
Okay.
Participants, our expert speaker is available. You can ask your questions.
Hello, am I audible?
Yes, sir, you are, please.
Thanks for the nice session, ma'am. You said that the stock market prediction uses semi-supervised learning, right?
Yes, sir.
Even the prediction of prices can be using regression as well, right? That is what I just wanted to clarify.
Yes, sir. Regression can happen, sir. But when you increase the number of parameters which are involved in the prediction, then your regression models may not be sufficient. So there is where you'll have to move from supervised learning to an unsupervised learning or a semi-supervised learning environment. So if you have just 2 or 3 parameters, fixed parameters, then yes, your regression might work. But now you have a lot of dynamic parameters which are involved. So in that case, you can move on. Better prediction comes through semi-supervised or an unsupervised learning models, sir.
Okay, ma'am. Thank you. I am basically from mechanical engineering. We'll contact you for any further clarification through mail, madam. Thank you.
Definitely, sir. Definitely. I would be happy to help, sir. Your name, sir?
Yeah, I'm Chandrakumar from Bengaluru, RV College of Engineering.
Good to know your name, sir. You can always contact, sir.
Thank you. Thank you very much. Thanks for the nice presentation.
Thank you, sir.
Yeah. Any more questions from the participant side? we can wait for another 1 more minute. Participants, you can ask Madam. Madam is available. If there is no questions, I think we can wind up. Officially, let me just thank our Madam Bharati ma'am, professor in Computer Science Engineering Department of Satyabama Institute of Science and Technology, for giving us an opportunity to have her presentations in our FDP. Thank you very much, madam. It is a very nice presentation. Wonderful presentations we have heard. Very nice, madam. Thank you very much.
Thank you, madam.
Sir, thank you very much, sir. Thank you very much.
Thank you,
sir. Thank you very much for inviting me, sir. Thank you for the opportunity
Sure.
given.
Sure,
I hope I was able to give some useful information. For people who said that they want to later, my mail ID would be, I'm not able to use the chat box. It will be bharati.csc. I'll just type here. If my screen is visible, just give me a minute, sir. I'll just once again, sir. Okay, I'm just leaving my mail ID here.
Ma'am, you would be sharing this PPTs and materials, ma'am?
Yes, madam. Actually, in YouTube it is available, madam.
They can use this mail ID, sir.
Okay, ma'am. Thank you, ma'am. Bharati, ma'am. Thank you for giving your valuable time for us. Thank you very much, madam.
Thank you, ma'am. Thank you, sir. Thank you for the opportunity. I will
Yes,
share the PPT also, sir. Thank you.
Okay, ma'am. Okay. Thank you. Thanks a lot.
Sir Kannan sir, thank you, sir.
Welcome, sir. I think we can.
Sir, feedback already I shared feedback in the comment box. In
Feedback you have shared, sir. I'll see that.
I already shared, sir. Okay, sir. Thank you. Thank you.
Okay, sir. Thank you very much, sir. I think you can close the session, sir. Thank you very much.
Yes, sir. We can close, sir. Okay,
Yeah.
sir. Thank you.
Welcome.